boards. Got some new FPGA boards for the ROMulator and new version of the ROMulator Z80 board that has those signals connected that we needed before. And I'm very much looking forward to testing this out, and that will be covered in the next video. But today we're going to be looking at these new boards that came in, and anybody who's had occasion to order more than a small number of circuit boards assembled is probably familiar with the feeling of nervousness or trepidation that comes from the first time you test it, and you're wondering if you have spent money on a bunch of drink coasters or if they're going to work. So today we're going to test out these new FPGA boards, find out if they're working, and if not, figure out what to do about them. And after that, we're going to look at a development which makes it much easier to work with the ROMulator if you're going beyond the settings with the default firmware. If you want to add your own custom ROMs or change the configuration of the enable table for the memory, we'll take a look at that as soon as we check out the FPGA boards. So first I got one of the new boards built up with the headers on it and programmed with the latest firmware. And now let's try it out on our handy PET 8032 over here. Make sure the switch is set to the correct setting. Let's switch 2 for this one, and we will hope for the best. So you can see what happened here. The light went on the ROMulator, but there was no startup chirp on the 8032, and the screen is black, so something is not quite right. So for comparison, I programmed one of the old boards, and you can hear that the startup chime did work this time. So it is something specific to the new batch of boards. So let's see if we can figure out what's going on here. So on this FPGA board, the first thing you do is you go ahead and program it with the firmware for the ROMulator. And the way that works is you connect it to either the Raspberry Pi or a standalone programmer. And when you are programming it, you're actually not directly programming the FPGA itself. You are loading the firmware onto flash memory here. What happens is the FPGA is held in reset while the flash memory is being programmed, and during the programming process the bytes written are read back and verified. So I think that we can be reasonably sure that the flash memory is working on these boards because the verify is happening. And after that, on startup, next thing that happens is FPGA comes up, the light turns on, which we see is happening, and it reads a value on the dip switches. What happens with that is that these dip switches are actually connected. They're sharing the data bus with the FPGA behind one of the buffer chips here. So when you start up, everything's basically disconnected from the CPU, and you're switching on or off some pull-ups, or actually pull-downs, I should say. You're switching down these pull-down resistors to ground. So what it should do is it should either read high or low depending on how you have your switch set. So the setting that you get from the dip switches determine an address you read in flash memory when you read in the contents of memory after you start up. So it figures out the address based on the dip switches, reads the appropriate section of flash, and programs the memory on the FPGA so you're ready to handle the memory map when you start running. So it's possible that if you're reading the wrong value on the dip switches, that could cause a problem. Or if something is happening between the FPGA and the flash when starting up and it's not reading properly, so that's also possible. But I think easiest thing to check is the switch settings and verify that those are either working or they're not working on startup. So the way we can check our switch settings is, let's see, we have our switch setting to switch number 2 is on, and that's the right setting for the PET 8032 that I was testing it on. What I can do is I can go ahead and I can reset the device, and we should see here, we should see the light go on. Yep, so we reset, and that means it has reread the switch settings, and we can use the console, debug console, and we have an option to read the config byte. Okay, config 31, or I guess that's 31 hex is the way it's formatted, which that is that's not right. So that config should be 2 because it's byte, it's the second bit, so that should read 2. So definitely that's not working. Let's switch that switch to off, so they're all 0 now. And I have to quit this and reset again. And now let's read config byte again. Okay, now the config is hex 30. Well, that's not right either. Let's try turning, let's turn some more switches on, see what happens. And turn the first 4 switches on. So that should be, there you go. So that should be hex, that should be, what is that, F, I guess? 15. Reset again. And let's read the config byte. It's 31 still. Alright. Okay, switched it out with one of the old boards. This seems to be working, but let's just confirm. Alright, we still have our switches 1 through 4 on. So I believe this should be, it should read as F, if I'm not mistaken. So let's reconfig byte. Or 15, I guess it is decimal. It's printing decimal. So 15, that's correct. And just confirm that the console program is printing it out in decimal, not hex. So that 15 is correct for the old board. So that's interesting. The new boards, every time you're reading the switches, it seemed to be toggling between 30 and 31. So let's take a closer look at our handy schematic for the, this is for the ROMulator 6502 interface board here. That's not the FPGA board, but it is important because this is how the switches read their values. We have the dip switch here, and we have a number of pull down resistors connected to the different lines, and these are connected or disconnected from what I'm calling RD0 through RD7. These are the data lines going straight to the FPGA. And they are also connected here. This is one of these 245 buffers. And when the device starts up, these are, the outputs are all disabled. So basically you just you got a direct connection between the FPGA pin, and you can either switch this resistor on or off. Now something that occurs to me is that those FPGA pins, I believe, have internal pull-ups. So at least that's what I observed when working on the old boards. But possibly those are not active, because if that was true, then these values would be more or less floating. But I just don't understand why it would be different between the two boards, because the boards are basically identical. Let's take a look at our verilog code and check in the setup for those data pins and see if there's anything interesting there. So I'm here in the depths of the Verilog code for the ROMulator, and I'm looking at the setup for each of these data pins. This is a special object that is for the specific type of lattice FPGA that I'm using. It's the SBIO primitive that you use. And something that jumps right out to me is there's this pull-up parameter here, and it's set to 0. This is a 1-bit value and binary value, and the value is 0. So that means that all of these pins are actually have the pull-ups turned off. Now this is one of these things where it leaves me a little perplexed, because I don't quite understand how it was ever working in this case, because I would think that you would always see a problem, but obviously that's not the case. The old boards were actually very consistent in working even with this parameter turned off, but obviously this is definitely a bug. This pull-up should be on. This is also well, this one I guess doesn't matter. This is the SPI clock, but these other ones for the data lines, the pull-up should all be turned on. Otherwise that value is going to be more or less floating. So I think that's exactly what we're seeing. We're reading not necessarily random values, but they're clearly not reading the pins properly. So I'm going to go ahead and turn those pull-ups on, and we'll try it again. So I made that change to turn the pull-ups on, and then reprogrammed the FPGA board with the new firmware. Okay, so we have all the switches set to 0. Oops, here you go. So reset. Let's see what our config byte is now. Okay, 0. That's good. That's good. All right. I'm going to switch it. I'm going to switch 1 on. Switch 1 is on. Let's reset again. Oops. Let's make reset. And here we go. Config byte. Config byte is 1. All right. All right. Try another one. Let's just switch 2 on as well. And let's reset. Okay. Config is 3. Okay, good. Oh man. All right. Well, that is good to know. All right. I have the board programmed with the pull-ups now turned on for those little data lines on the FPGA, and here goes nothing. Oh, okay. All right, good. Good. And yeah, there you go. Here, let you see that. It came up to the normal prompt, and we are happy. So something about the old board versus the new board means that the new board doesn't read switch values properly with the pull-ups turned off, whereas the old board seems to be tolerant of it. And yeah, it's an interesting one. The boards are not only, the board itself is, the design is identical, and the parts are all identical. They're not even equivalent parts. They're the exact same part numbers. And the only difference really, this is the old one, this is the new one. But the only difference is the board itself was made by a different provider, and the assembly was done by a different provider as well. So those are really the only variables here. And I just have to guess that there's something about the old board that, I don't know, slightly different resistance in the lines, perhaps, different capacitance, I'm not sure. But that was clearly a bug, and just one of those moments where you have to wonder to yourself, how did it ever work? So if you're using the ROMulator and you ever see any issues like the switch is not reading properly or occasionally not starting up, then I would definitely recommend getting the new firmware update, and I believe that's going to make it a lot more stable. So I would consider it an important update. But the good news is I have these new working boards now, so I can start making ROMulators again, which is great. And the second thing I was going to talk about was a way to make the ROMulator much easier to use for anybody who's doing something beyond just using the default settings that are preloaded. And those default settings are pretty heavily oriented towards the Commodore PET, but then there's a few other things, Apple II Plus, VIC-20, etc. But on many occasions you might want to change this out with different ROMs, support different machines, or change your memory configuration. And as you might have noticed, this README is getting to be kind of a dense wall of text here. If you want to change anything, you end up having, if you're on the Raspberry Pi, you have to go ahead and install everything on the Raspberry Pi, install the whole build system for the FPGA and everything. Or if you're using the standalone programmer, then you have to install the build system on another computer. And if you're using Windows, then you have to go ahead and install a whole separate Linux distro on with the whatever it's called, Windows subsystem for Linux. It's kind of it's a heavy operation for just changing some settings on the ROMulator. So and it's been mentioned to me a couple times, like, is there any easy way to do this? So good news, the answer is yes, there is. At least there is now. So to explain what was going on with the build system before, why it was sort of complicated to make any changes on the ROMulator, let me just talk a little bit about what's going on startup with the FPGA and kind of how the FPGA works in general. Basically, this particular FPGA, I'm not sure if it's true in general for all FPGAs or not, but this particular one, the Lattice ICE40 UP5K, what is it, SG48i, I think. What happens is when you power it on, automatically it attempts to read its own bit stream, and the bit stream is basically what tells the FPGA not really what to do, but what to be. It's a stream of bits that turns on and off all the switches and various cells in the FPGA and makes it behave in the way that you want it to behave. And that bit stream is stored on flash. So the FPGA starts up, it loads the bit stream from flash, and then it starts doing what you told it to do. And in our case, after it starts up, it will also it reads the switches, like we said, and it turns that into an address on the flash, and then it reads the 64K memory map that you've selected, and it reads it into its own internal RAM. So the structure of what I'm calling the firmware on the flash here is it starts with a bit stream, and then there's a little bit of empty space just to align it with a 64K border, and then you have 32 individual 64K memory maps, and those are selected with switches 1 through 5 on the ROMulator here. That used to, in the older some of the older versions of the board, there are only 4 switches, so you can only pick 16, but now we're using 5 switches to choose between 32 different memory maps and settings and enable tables as well. But one of the things that is sort of holding us back from making it a little bit easier to switch out those settings is that the enable tables on the FPGA are not read from flash. Those are actually pre-programmed into the bit stream itself, and that's not easy to change, not without running the entire build system again. So that's why you end up having to either run the whole FPGA build either on the Raspberry Pi or on another computer, your Windows, Mac, Linux computer. So the change I made was to take that enable table, and now it's actually going to be in flash. So it's going to be read from flash, and it's going to be read in at startup. So that means that in the future you don't have to run that build system anymore. The bit stream will remain the same, and you just have to construct the memory maps and enable table, put them in flash, and then they will just be read from they'll be read from flash at start. So you can you can change those very easily without changing the bit stream. And I've made a little tool for doing this that doesn't require any installation on any computers, and let me show you how that works right now. So put together a little very minimal web application here at my site bitfixer.com/romulator-build, and when you go there, you've got this very beautiful page here. And what you do is you're just going to upload a zip file that contains your memory set definition and your enable table definition. They just need to, that zip file needs to contain something starting with memory_set, and then anything you want, .csv, enable table star.csv, and also needs to contain all the ROM files that are referenced in the build. And when you do that, you will receive the romulator.bin file, which it contains, it's like we were talking about before, it's the bit stream followed by all the memory maps and then the enable table, and then you can use that. You can take that romulator.bin file and just program it directly with your standalone programmer, or you can copy it onto your Raspberry Pi and program it from there. So let's go ahead and try that. I have this file here. So contents of my zip file here are just all these ROMs. These are all ROMs. And then we also have this memory set default. Well, you can't see that. I'm using the memory set default file, enable table default file, and along with all these ROM files. So that's what's in the zip file I'm about to upload. So I'll go ahead and upload that. And there we go. We got our ROMulator, or I guess I already had one in there, romulator1.bin. That's what happens if you have more than one in your downloads file folder. But you can just take that, program it straight onto your device, and you're ready to go. You no longer have to install a build system. I think it will make it a lot easier, and save a lot of trouble in needing to install a bunch of tools if you're just going to change your memory maps and your enable table. Everything else will remain the same. If you want to change some more core functionality of the ROMulator, you can do so, and you can still build in the other way. But I think this will just simplify things if you're just trying to add some new ROMs for a new computer. So I hope that is helpful and that's useful to you. So I think that will be it for this time. Just a little bit of an interesting debugging story here with these boards with the mystery problem, and an update for the ROMulator to hopefully make it a lot easier to work with. If you enjoyed the video, please feel free to subscribe to the channel. I'll be back very soon with another installment in the Z80 saga here. I've got these new boards, so get those built up, and we will test out on some Z80 machines, and hopefully this time with a little bit more complete success. We'll see. Thanks for watching, and see you next time.